everyone, this is Maurizio, Editor-in-Chief of Power Electronics News, and today I am here at PCIM showing in Nuremberg, and I have the pleasure to be here with HelenAnn Brown, Technical Marketing Manager at Apex Microtechnology. Thank you for being here. How are you?
Thank you.
So, let's start to introduce yourself and to introduce your company. Please share us a bit about your background and expertise in terms of Apex Microtechnology.
So I'm HelenAnn. I work as the Technical Marketing Manager at Apex Microtechnology. I work primarily on new product development, so I think all of the very exciting products and all the secretive fun stuff. But I really enjoy everything that I do for Apex. So Apex is located in Tucson, Arizona, and we've been around since 1980 producing high power products, linear and switching amplifiers, and we're excited today to talk about some wide bandgap material, advanced packaging, and all of the latest and greatest from Apex. So I'm excited to share that with you guys.
Indeed, the big topic is wide-bandgap. That is running also at PCIM as well, so like silicon carbide, like gallium nitride, they are transforming the power electronics market. So how is your company leveraging this technology to improve, to enhance the performance?
Yeah, wide bandgap material, in my opinion, is transforming every aspect of what we're doing, because not only is wide bandgap material transforming the material itself and its properties in terms of pushing voltage and current and the boundaries of power, but it's also really helping us with power density, right? All of our customer applications and what we do at the core of Apex is getting things small as possible and pushing power density. So silicon carbide and wide bandgap material, GaN as well, is allowing us the opportunity to do that. And that's through advanced manufacturing. It's also pushing the boundaries of testing, and it's pushing the boundaries with material as well. So it's really changing every single aspect of what we're doing with respect to some of these power modules and our level of integration.
Talking about silicon carbide, I would like to share about silicon carbide modules. So this is going to have to do important in terms of market. What about packaging innovation? Because the goal is to reduce inductance, parasitics, to minimize and improve the performance. What do you think?
Yeah, absolutely. So silicon carbide, as we all know, is best used at very high temperatures, very high power, and often a limitation to that is the package itself. So we're looking at that from a very aspect of every single piece in manufacturing. So all the way down to material, all the way to that package, and we're evaluating each individual aspect. So that is everything from the die attach method and how reliable is that, how can we improve that, to advanced materials, how can we make sure that every single material is thermally optimized to get the best out of silicon carbide. Also in terms of packaging, are we using the most advanced packaging, the most advanced form factor, are we able to get the power that we need from this wide bandgap material, which is core of what we're trying to do. So it's really pushing packaging in a really advanced direction and pushing us to make sure that our manufacturing is on top of using this wide bandgap material and being able to get the most out of it for the applications as well. All of the applications that Apex serves are high-rel industrial applications. So we service everything from aerospace, high-rel industrial, semiconductor equipment, as well as medical. So all of our applications really are high reliability. Failure is not an option. So we are evaluating the packaging from every single aspect that we can.
So Apex is also known for its strength about in analog. So what about the integration? So how are you integrating mixed signal IC design capabilities to meet the next demand in terms of application size, such as precise control, motor drive, and so on? What about integration in this case?
Yeah, so it's twofold. So when we talk about wide bandgap and we talk about silicon carbide, we have our integrated power modules, and those feature a level of integration. I think module, at least in our industry, is kind of a loose term. We say module a lot, but sometimes it's packaged MOSFETs. But when we talk about an integrated power module, it's the gate driver, it's the MOSFETs, the protection features all in one package. And now, as we start to talk about our precision ICs and mixed signal is not new to Apex. We've had mixed mixed signal devices before, but more of our open frame product line. And now we're starting to incorporate them in ICs. Back at the beginning of the interview, I said our customers are going as small as possible. And this is true across the board with all of our product lines, even our IC product lines and our linear amplifiers. So we're now going from our hybrid products, which was miniaturizing a board, to now going into using a monolithic die. And so we're utilizing things like a built-in DAC to incorporate more features into our single die. So we want to be recognized not only for our hybrid products now, but really think about Apex for things like precision ICs and monolithic die as well.
So, in conclusion, HelenAnn, let's talk about manufacturing. So, what's next in terms of state-of-art manufacturing? How you are improving in terms of integration, in terms of tighter solutions. So, what about the investment in terms of manufacturing to support innovation in terms of performance and so on? What's next?
Yeah, of course, miniaturization brings its challenges, right, to manufacturing
Always
and operations. Yes, it is. But of course, customers want it as small as possible. We want it to be as small as possible. So we are optimizing our manufacturing for that. So that's everything from different interconnect methods. So also looking at, how can we wire bond? Is there different die attach methods that we can be using, as well as, maybe using pressure sintering, soldering, different attach methods. Also pushing the boundaries of test, with wide bandgap materials specifically, there's a lot of different tests that now have to be introduced, things like double pulse testing. So incorporating those into our manufacturing, in addition to things like automation, how can we continue to miniaturize our products, introduce automation, less variance in our products, ensuring the highest quality and the highest reliability through simulations, through testing, and through modeling for our customers. So it's certainly something that's at the forefront of what we're doing today at Apex.
Thank you so much. Thanks a lot. Have a good
thank
day
you for having me.
at the PCIM and stay in touch.
Yes,
Thank you.
thank you.
Thank you. Thank you. Thanks for watching.